Okay, today we'll start jet transformation and difference equations. Actually, difference equations is another topics, but the combination of jet transformations and difference equation we will discuss today. We have already finished about the jet transformations, and this is the last class for jet transformations. And today we will try to learn how to solve difference equation with the help of jet transformation. And this is the last class for jet transformations. Actually, difference equation and jet transformation. And before starting this, we will try to overview an jet transformation with a slide presentation. Mm, okay, before starting this, just an overview of jet transformation. Actually, why jet transformation? We have studied about this. There are different types of application of jet transformation. The jet transformation introduced polynomials and rational functions in the analysis of linear time discrete system, and it has a similar importance as the Laplace transformation for the continuous system. You must know, for continuous system we have to apply Laplace transformation. Convolution becomes a multiplication of polynomials. Convolution, we have studied about convolution theorem in on Fourier, also in also Z transformation. And carrying out the Z transformation in general leads to the function consisting of a nominator and denominator polynomials, and the local of the roots of this polynomial determines important properties of digital filters actually. And time domain, here you must know about this single process signal processing, impulse response, difference equation, real signal domain. Actually, you have to uh, define the domain in jet transformation like this, and frequency domain like this: frequency response, spectral representation, analysis of sound, etc. And Z domain will be operator, poles, zeros, mathematical analysis, synthesis. Actually, we use this in complex analysis. Now, input signals: impulse, complex exponential function like this, and jet transformation can be written as the sequence like this. Z transformation FIR filter, actually this is the using signal for xn equals to z to the power n for all n, that is the arbitrary complex number, and as input signal, this is the signal can be represented by this yn. This is the solution of, this is actually by the definition of jet transformation. And hz equals to this is the system function, and z equals to e to the power this, it is the known function for us. The system function hz and the z transform of the impulse response. The system function of a rational function, this is actually jet transformation by the sequence, and numerator polynomial, this numerator, and denominator would be z square. This is the division of two polynomials. Now, impulse response can be represented by this, and it can be transformed to jet transformation like this. We have solved, we have transformed different kinds of polynomials and impulse response to this. That means solving, we get this this transformation. This is called jet transformation. A representation of signals with the jet transformation, we can represent it as a signal. Okay, we can represent it as a signal. Okay, signal of finite length can be represented by this sequence. Okay, this is the combination of sequence xn, and z transform of this signal can be represented by this is the by the definition of z transformation, and this is the system function after z transform. Then z transform, z is called actually z transform of xn, we must know. And the and z inverse of xz is a polynomial in z inverse. The coefficient are the values of the sequence, and you can tabulize these values for different n. Okay, we get xn. like this. Actually here in this there are many terms, okay, but there are different values of xn depending on n, okay, and n is less than -1 to n greater than 5, okay. This is the n domain and z domain after z transformation, and this is the given sequence. So given sequence after we can transform z transform like this. Actually this is the discrete Fourier transform, filter transform, sorry. The system z can be the complex variable z and z transform of a filter. We have studied this actually. Yn can be uh, represented like this. This is the actually difference equation, like a polynomial, and z will be 6 minus this. This means this is the actually after z transformation of this. There are different kind of zeros. Zeros means what? This equals to 0 and z minus half equal to 0 and z equals to 1 by 3 equals to 0. Then we get these two zeros. Z equals to what? 1 by 3 and z equals to half. We get 0 here. We have studied many properties of Z transform, linearity property, time delay property, and we have solved different kinds of problem using these properties. And Z transform as operator, okay, unit delay operator D, yn, xn, yn. We have used this in our previous lecture using these properties. Actually, this is the block diagram and application of Z transformation. Convolution theorem we also studied of Z transform, the linear time, and linear time independent. Partitioning we have also solved like this problem using these partitioning properties. Poles and zeros we have found by using Z transform of a complex number sequence. What does actually mean by zero? The complex input signals for z1, z2, z3, etc. we get 1 and e to the power this and e to the power minus z pi this. Actually this is the exponential function depending on period pi. This is the application of Z transformation and application of Z transformation, and this is also application of Z transform, and this is the actually Z transform of a function. We got this Z transform, and you can draw the level diagram of this. This is also a linear, and it is the logarithm function, and this is also a Z transform, a PN diagram, impulse response. This is the diagram of this Z transformation. This is also we can draw this by using this function. Implementing different software, actually you can implement MATLAB software, other software, Python, etc. First order FIR filter. Actually this is the example of application, and this is the huge application for different values of n, 0, 1, 2, 3, 4, 5, 6 putting we get this, and you can put it in a diagram. Actually filtering process, there is a great application on Z transformation. Output function f and in FIR output, this is the input, this will be the input, and this is the output function for yn, and this is the linearity property time we started this, and we have solved different kind of problem using these properties, linearing properties. This is the difference equation we are talking about, this difference equation of impulse response. Actually Sn, this is the actually sequence depending on n, and this is the equation. The solution is Sn will be b naught a1 to the power n for n greater equal to 0 and 0 if n less than 0. We can there is a proof for this. Since this is a sequence, we can use this equation. This is the difference equation of impulse response. Okay, this is a1 is n minus 1 b naught del n. Before this we have to define that if what is actually difference equation. Now we are going to our previous and this is the difference equation we are talking about. First of all, what is difference equation? Difference equation are the discrete equivalent of differential equation. Actually, discrete equivalent. Difference equation is used for only discrete values. And this is equivalent to what? Differential equation when it becomes discrete and defined in discrete function. The terminology is similar, but methods of solution have much in common with each other. Difference equations arises whenever an independent variable can have only discrete values. Understand? Any function y equals to f of x. If this function can be represented by discrete values, then then it will be difference equation. That means it will be defined in discrete values. The function will be defined in discrete values. Then it will be difference equation. They are of growing importance in engineering in BU. Actually, in your areas, there it has a vast application. They are growing of importance in engineering in view of their association with discrete time system. Discrete time system means you must know time will be independent variable. Time will be independent variable, and that means the dependent variable will depend on time. This is why this is the time discrete values, and the range will be discrete. This is based on the microprocessor. Actually, in computer, the microprocessor working for different in discrete values, because in every words there are bytes, then kilobytes, then megabyte, then gigabyte. These are all are discrete values, and they have to arrange in an order with discrete, not continuous. Understand? Now, basic definitions of difference equation. Before classify difference equations, we'll first derive the example of one. Suppose a microprocessor system is being used to capture and analyze the image. That means a microprocessor system is being used to capture and analyze image. We are using microprocessor system to analyze what? An image. The number of instruction cycles I of the microprocessor needed to process an image and depends on the number of pixels. That means the image you have taken with the microprocessor system, and this image will depends on number of pixels. Higher pixels will give a better image. Okay. Suppose pixels are n, that the image is broken down into. Image of course will be broken down for different kinds of pixel. So to combine the whole image in a beautiful way, the pixels, the number of pixels are very important. So classify n is a non-negative integer. That means n of course belongs to natural number. Since I depends upon on n, we can write I equals to I n. Okay, within third bracket n. The square bracket notation reflects that the n is discrete values. This third bracket indicates what? Discrete values n. N will be not continuous values, and this will be discrete. That means 2, 5, 3, 4, 5, 7, 10, 11, 14, 18, 7, not continuously. Okay. The square bracket notation reflects that n is discrete variable. If there are n times of data, the number of instruction cycle used as in. Okay, if there are n items of data. Suppose that if there are n plus 1 item of data, suppose we have n plus 1 items data, the number of instruction cycle used by increases by 10 times. Okay, 10 n plus 1. That means this will be increased by 10 n plus 1. Cycle will be increased on 10 n plus 1. That means in plus 1 what will be equals to in plus 10 n plus 1 cycle. And this is the example of difference equation. The dependent variable what? Dependent variable what? I. And independent variable is n. Actually n is not number. This is the look like variable. Okay, but this n belongs to what? Natural number. Remember it. This small n will be belongs to capital N. So this is an example of difference equation. The dependent variable is I and independent variable is n. Putting n equals to 0, we get here. Putting n equals to 0, we get I1 equals to what will be I0 plus 10 into 0 plus 1 equals to what? I0 equals to what will be? Only 1. We get only 1. Similarly, I2 what will be? Just putting n equals to 2 here. N equals to 1. 1 here. Then I2 equals to what will be? I2 equals to 12. 12 how? Put n equals to 1. I1. I1 equals to what? I1 equals to 1. Then 1. 10 into 1 what? 10 into 1? Only 10. Okay? 10 into 1 is only 10. And this one make what? Total 12. Now I3 what will be? Just putting n equals to 2. I3 what will be? I3 equals to I3. I3 what will be? N equals to 2. I2 equals to what was? 12. This is 12. So 10 into 2 what? 20. 20 and 12 what? 32 and 1 33. Okay. Now I4 what will be actually? And putting n equals to 3. That means I4 what? I3 what was? 33. 33 plus 3 10 30. 33 plus 30 what? 63. That means plus 1. 63 plus 1. That means 64. Okay, and so on. Just look like a sequence. We see that the difference equation gives rise to sequence of values. Understand? Okay. Now dependent and independent variables of a difference equation. Okay. Now what is the dependent and independent variables of a difference equation? Consider a simple difference equation. Suppose this is the given difference equation, xn plus 1 minus xn. Actually n is the dependent variable, independent variable, and x is the dependent variable here. This equals to 10. The dependent variable is x and the independent variable what? Is n. So in the given difference equation, we can in the difference equation yk plus 1 minus yk plus 1 minus yk equals to 3k plus 5. The dependent variable is y and the independent variable is k. So dependent variable, independent. Now solution of the difference equation. A solution is obtained when the dependent variable is known for each value of interest of the independent variables. Thus the solution takes the form of a sequence. Actually the solution also be a sequence because the difference equation look like a sequence, and the solution also gives sequence. There are frequently many different sequences which satisfy difference equation. That is, there are many solutions. The general solution embraces all these, and all the possible solutions can be obtained from it. Suppose there is an example, we can study the solution of the difference equations, not differential equation. Actually is the show that xn equals to a into 2 to the power n, where is the constant is a solution of this. Now we have to prove this is the solution of the difference equation. This xn plus 1 minus 2xn equals to 0. Suppose xn equals to given a into 2 to the power n. So xn plus 1 what will be? Just replacing n by n plus 1. We get a into 2 to the power n plus 1. That means this can be written as a into 2 to the power n into 2. Okay, a into 2 to the power n into 2. This can be written as. So this also can be written as twice a into 2 to the power n. Hence, the given left hand side of the difference equation, xn plus 1 minus twice xn, just putting the values, we get what? 0. That means left hand side and right hand side is 0. Hence, the xn equals to a to the power a into 2 to the power n is a solution of the given difference equation. In fact, xn is the general solution, not particular solution. This is the general solution. If additionally we are given a condition, say x0 equals to 3. Suppose there is an initial condition for n equals to 0, x equals to what? 3. For n equals to 0, x equals to 3. Now imposing this initial condition to the above difference equation where constant is a can be found if xn equals to a into what? A into 2 to the power n. This is the actually solution of the above difference equation, xn equals to a into 2 to the power n. So now just putting n equals to what? 0. Using this initial condition, when n equals to 0, x equals to what was? 3. So just putting n equals to 0 here, x0 equals to a into 2 to the power 0, a into 2 to the power 0 means what? 1. So a into 2 to the power 1, 2 to the power 0, the into 1 equals to only a. That means x0 equals to what? A. But in our initial condition, x0 what was? x0 equal to 3. This is why a equals to what? 3. Now we can put in our solution a into 2 to the power n. Thus, just putting the values of a, we get xn equals to what? 3 into 2 to the power n. Actually, this is the particular solution of our given difference equation, and this is the specific solution and satisfy both the difference equation and given condition. Now linear and nonlinear equations of difference equation. Linear, when it will be linear and when it will be nonlinear. An equation of linear of the dependent variable occurs only to the first power. Dependent variable what will be? Only for first power. If an equation is not linear, then it will be must be nonlinear. So for example, 3 into x of n plus 1 minus xn equals to 10. This is the difference equation, and this is also a difference equation. This is also difference equation. And yn plus 1 minus 2 into y n minus 1 equals to n square. And k into z, k plus 2 plus zk equals to z into k minus 1 are all linear equation. Okay, because highest power of dependent variable what? 1. Here dependent variable what? X. And in this dependent variable what? Y. And in this only z. And dependent variable is n and k. All are linear. Note that the present of the term n square does not make the equation non-linear because n is the independent variable. Dependent variable, if the power of dependent variable will indicates the number of linearity. Okay, whether it will be linear or non-linear. The power of dependent variable. Dependent variable here what? In first equation dependent variable is x. So power, highest power what? 1. And in second difference equation, the dependent variable is what? Y. So highest power is 1. This is why this is also linear. Linear means just power will be 1. Now, however, if we take these types of difference equation, x n plus 1 whole square minus x n equals to 10, or y of k plus 1 equals to square root over y k plus 1, these types of equation, that means these types of difference equations are non-linear. and both nonlinear, because you must know there is a square term and there is a square root term. This is why this makes this difference equation nonlinear. Also, Zn plus 1, Zn Zn plus 1 into Zn equals to n square plus 100, and sin xn equals to x into n minus 1 are nonlinear. The product, actually there is a product, n plus 1 into Zn. This is why this differentiation equation becomes nonlinear for this product. And sine function, you must know, sin xn are the cause of nonlinearity, because this is the trigonometric function. Now what will be the order? Actually, there is a similarity between difference equation and differential equation. You must know uh, the degree of linearity and non-linearity of differential equation. You must know in first semester or second semester you must have studied. But in difference equation we are learning about the order now. The order of the difference equation will be the highest and lowest arguments of the dependent variables. Order will be what? Order is the difference between highest and lowest arguments of the dependent variable. The equation, suppose the equation 3 into x n plus 2 minus x into n plus 1 minus 7x n equals to what? N. This is the second order, because the difference between, there is a highest what? Highest argument of dependent variable. Argument what? Entry. Entry means input. Entry means inputs. Inputs means argument. Argument means dependent variable. Sorry, independent variable. Arguments mean what? Independent variable. Remember it. So highest independent variable n plus 2, and lowest what? Only n. So difference what? Difference between n plus 2 and n is what? Taking minus n plus 2 minus n what? Only 2. This is why this equation is second order. Understand? And xn plus 1, xn plus 1 in xn minus 1 equals to 7 into xn minus 2. This is also difference equation, but this is the, there is the arguments. Arguments means independent variable. Highest independent variable what? N plus 1. Okay, and lowest what? N minus 2. So difference what will be? N plus 1 minus n minus 2, what will be? Only 3. That means this is the third order difference equation, and the higher order of the differential equation are more difficult to solve. Remember it. Okay, homogeneous and inhomogeneous equations. There are two actually. This is the difference equation, and it can be written as like this. Okay, this is a constant term. Okay, right hand side is constant term. Actually, when we apply it to when the difference equation used to in using in differential equation, then it will be important to determine the homogeneous and inhomogeneous equations of difference equation. Actually, right hand side here 2n cube, right? Twice n cube. Twice n cube is the right hand side. So right hand side is not 0 here. Okay, to be a homogeneous difference equation, right hand side must be 0. Okay, but second example, the equation is not, first difference equation is not homogeneous, but here second example we can write 3n x n plus 1 minus x n minus 1 equal to 0. This is homogeneous because right hand side is 0. Understand everybody?
Yes, sir.
Okay, there is an engineering application in signal processing using a microprocessor. Actually, microprocessor in computer, in engineering and increasing number of product containing a microprocessor or computer, which is solving one or more difference equation. You must know about the microprocessor when in 1974 it was invented. But using this difference equation, they have developed microprocessor, and we are using most powerful computer today, but with the help of this difference equation actually. So there is a huge application of signal processing using a microprocessor. And this is the difference equation yn minus 2 into y n minus 1 0.1 sn. Here n is the actually independent variable independent variable, and y is the dependent variable. Remember it. And what will be the order of this difference equation? Can you tell me what will be the order? What will be the order? Actually, right hand side non-zero, right? Right hand side non-zero. This is why. What will be the order? And homogeneous in okay, non-homogeneous. And order what will be? Difference between lowest which one? Actually n minus 2 and highest what? N. So difference what? N minus n in n minus n minus 2 what? N minus n minus 2 what will be? 2. This is why this is the second order difference equation. Understand?
Yes, sir.
Okay. So where yn is the output sequence. You must know this is the dependent variable, and dependent variable y of course gives the output or dependent variable, and sn is the input. Actually sn is the input sequence. Note that the input sequence can still be thought as the independent variables, but instead of being expressed analytically in terms of n, it arises as a result of sampling. Actually in sampling method, in the statistical process, in difference equation, because for discrete values there are huge application in statistics. Okay, in probability distribution, in sampling, in hypothesis testing, in chi-square testing, and in normal distribution of course in for continuous. This is the difference equation, and this is the homogeneous difference equation. So there is it has an application in what? Signal processing using a microprocessor. This is very important for you. Now what is the coefficient? Actually the term coefficient refers to the coefficient of the dependent variable in any difference equation, not differential equation, remember it. In difference equation, the coefficient what will be? Coefficient will be the refers to the coefficient of the dependent variable. Understand? In equation 22.1, in equation 22.1, this actually what will be the coefficient of dependent variable? What can you tell me? Coefficient of dependent variable? Thrice n and minus 1. Coefficient what? Thrice n and minus 1. Coefficient of thrice n. Okay, dependent variable what? X. In this equation, dependent variable what? X. So x, and independent variable is n. So the dependent variable coefficient what? Thrice n, and in this x dependent variable coefficient what? Minus 1. This is the actually coefficient of difference equation. Now we will study some examples. State the order of each of the following equation 1 and 3, and in B state the whether each equation is linear or non-linear. Okay, we have to test this whether linear or non-linear. And in C, for the each linear equation state whether it is homogeneous or non-homogeneous. That means we have to examine which difference equation is linear and which difference equation is non-linear, and we have to test and we have to verify the homogeneous or inhomogeneous, whether it is homogeneous or inhomogeneous, and whether it is linear or non-linear. And we must find, we have to find out the order of each equation 1 to 7. Actually there are given 7 equations and all are difference equation, remember it. In first difference equation, what will be the order? Actually order will be what? Highest. Order will be difference between highest and lowest arguments, right?
Yes, sir.
2. And in this also second order, right? And in third, highest what? N plus 2. Lowest what? N minus 1.
Minus 1.
Difference third. In 4, highest what?
N plus 1.
Now this is the constant term actually.
Okay. Eight, sir.
That means N minus 1 highest and lowest N minus 2. Difference what will be? Only 1. That means first order. So in 5, highest what? N plus 3.
Lowest, let's
uh,
say N
N
cube
plus
minus
2
1.
1. N plus 3 and N plus 1. So difference what will be? Only 2. Okay, second order. Now in 6 will be similar. Highest what?
N plus 2.
N plus 2 and lowest what? In left hand side?
N plus 1.
Difference what?
1.
1. And in right hand side also?
Highest N plus 2. N plus 1. Lowest N plus 1.
N plus 1. Lowest actually this is the dependent variable. Dependent
Variable.
variable. We have to test the dependent variable. Remember it. So this is the first order and this is also third order. Okay, using the same statement. Now in B, first one is linear. First one is linear. I hope everybody can solve this. This is the actual answer of this. And C, for C, whether it will be linear. Equation 3 and 5 are non-linear. Okay, why non-linear we must know, or maybe it may be using it has coefficient of dependent variable, right? If it has coefficient of dependent variable or right hand side is not 0, then it will become non-homogeneous. And homogeneous when right hand side is 0, and linear will be highest power of dependent variable. Okay, if highest power of dependent variable is 1, then it will be linear, otherwise non-linear. Understand? So the inhomogeneous will be like this. This is the actual example of finding this. We have solved this example. Can you do? You can do it. Now rewriting the difference equation. How to rewrite the difference equation? Sometimes an equation or expression can be written in different ways. At first sight, it may be appear there are two independent equation, when in fact there is only one. Actually, in every difference equation, it has one equation, but seems to be two independent equation. Actually not true. Thus, we need to be able to rewrite the equation so that comparisons can be made. When general solution of the equation are to be found, usually the equation is first written in a standard form. So once again, there are need to be rewrite equations. Suppose rewrite the equation so that the highest arguments of the dependent variable is n plus 1. Highest power is n plus 1. Actually, try to understand this example. Okay, 2.3. Try to understand. Actually, this is the given difference equation, and this is the what? Initial condition. Okay, for n equals to 2, x equals to 7. X is the dependent variable and n is the independent variable. The highest argument in the given equation is what? Highest argument what? N plus 3, right? And this must be reduced to by 2 to n plus 1. How? To do so, n is replaced by n minus 2. We can replace n by n minus 2. The equation becomes if we put n equals to n minus 2, then it will become what? N plus 1, and this will be n, and this will be what? 2 into n minus 2. That means we can rewrite this difference equation, and x2 will be 7, same. However, the initial condition are not changed. This is simply stating that x has a value of 7, and the when the independent variable has the value of 2. Actually, independent variable, this 2 is the independent variable values. Okay, for 2 independent variable 2, the dependent variable value of dependent variable is 7. Just rearranging. Okay, replacing n. Similarly, example, this example you can rewrite this. It is homework for you. Okay, write the following equation. The highest arguments of the dependent variable is n plus 2. Highest what? N plus 2. Just making n plus 2. Highest what in the first equation? N plus 4. So difference we can replace n minus 2. Okay, and in initial condition will be same. And in second one n is increased by n plus 2, right? N is increased by n plus 2. So n is replaced by n plus 2. Okay, n equals to n plus 2. And this difference equation can be written as this. And initial condition same. Similarly, we can rewrite this a and b also. Block diagram representation of difference equation. Actually, in many engineering system can be modeled by many difference equations. It is possible to represent difference equation pictorially by means of block diagram. Okay, suppose xn. This is there is a dependent independent variable n and dependent variable x, and this is the discrete system because the value was discrete values 6, 4, 3 random numbers, and n equals to what? Serial. N equals to serial. So we can rewrite this as x0 equals to 6. X0 what will be? 6. X1 4, x2 3, right? We can write in a sequence like this, and then x n minus 1 what will be? X n minus 1, putting n equals to n minus 1 in this sequence, we get 0, 6, 4, 3 like this. For n equals to 0, n equals to 0 what will be? For n equals to 0, this will be value 0. For n equals to 1, x0 what? X0 6, this is why 6. And for n equals to 1, that means x0 equals to what? 6. For n equals to 2, x1 equals to what was? 4. This is why this is the serial of xn minus 1, and this is the serial of xn for individual values of n. So we can rewrite in a block diagram like in figure A. This is the continuous signal. It's continuous signal. There is no discrete values. Okay, just for different in time t, the xt will be this. Okay, xt is in y-axis and t is the x-axis. Now sequence produced as a result of sampling for different samples for different values of n. Okay, we get xn, different values of xn. This is actually the discrete diagram, discrete values. Now we can rewrite the block diagram representation of a difference equation. So xn will be input and output will be xn minus 1. Okay, just this is the a delay sequence by a time interval t. Here interval what? Between these two sequence, capital T. And if two delay blocks in series, just 2 time 2 t. Difference between this what will be? These 2 times. Okay, there are 2 blocks. Now adding a constant to a sequence, if we try to add a sequence xn plus a, that means a constant, adding a constant plus, adding a constant will be plus, like this diagram. By scaling a constant, scaling a sequence by a constant, This will be multiply notation, and if we adding, this will be summation. Okay, summation notation. This is actually this block diagram used in sequencing the difference equation. Remember it. It has and this application actually happened in engineering application. Now in another application, discrete time filter. For this, the term filter is used by engineering to describe the electronic device that selectively processes signals to different frequencies. For example, a low pass filter is a filter that allow low frequency signals to pass with little attenuation of their amplitudes. However, high frequency signal tends to a several attenuation. In contrast, a high pass filter attends a low frequency signals. Suppose that there is an example yn minus a yn minus 1 equals to xn, where xn is the input sequence. Okay, xn is the input sequence and yn is the output sequence. There is a two sequence and a is the constant. If a is positive, then the filter behaves as a low pass filter which rejects high frequencies but allows low frequencies to pass. If a is negative, then filter behaves in as a high pass filter. Okay, depending on a, this there are two individual values for xn and yn depending on a. If a is the negative, it behaves in one way, and if a is positive, it behaves in another way. So a block diagram for the filter shown in 22.7 actually in this. Okay, that means this difference equation can be represented by this block diagram. Okay, xn and summation, this summation notation, ay and minus 1. This will be in negative way, minus a y and minus 1. Okay, minus a y. This is why this passing to this and this passing to this, not going. If going will be positive. So if the coefficient of y will be minus negative, this is why it comes to this summation. And adding a constant to this yn minus 1, just yn minus 1, adding a constant, we get this block. And this is the xn input and yn is the what output. This will be the total output yn. Xn is the input, remember it. And this is the block representation of discrete time filter for this difference equation. Understand? And another engineering application for difference equation, development of a difference equation to calculate the acceleration of an object.
স্যার
স্যার আজকের ক্লাস আর কটা পর্যন্ত নেবেন স্যার?
দেখি না, শেষ করে দেব।
আচ্ছা।
Okay, development of a difference equation to calculate the acceleration of an object. Okay, acceleration you must know. A velocity what? Rate of change of displacement with respect to time. Okay, ds by dt. Acceleration what will be? Rate of change of non-uniform velocity with respect to time, dv by dt. That means acceleration can be represented by this, d square s by dt square, where s is the position or displacement and b is the speed or velocity and I is the acceleration. So therefore, in order to obtain an acceleration signal, the position signal must be a differentiated twice. Understand? This distance differentiated how many? 2 times, right? To become acceleration. So for a small time interval capital T, the derivative yt of a signal xt can be approximated by this. Yt will be approximated by xt minus xt minus capital T divided by t. This is actually time interval dividing by this, and this distance position signal can be changed to this.
কোনটা কি টাইম টেবিল বলুন স্যার?
Okay, if the signal xt is the sample to give xn, then the process of differentiation is represented by the difference equation. Process of this differentiation can be represented by this equation. Okay, that means yt can be becomes yn, and xt xn, xt minus capital T, what will be n minus 1, and this is the capital T. So from a block diagram for the differentiator, I have shown you in slide and also in above page, we saw the block diagram of difference equation. It is important to note that this difference equation is only an approximation to the process of differentiation. Okay, this could be implemented using special purpose hardware or be software on a microprocessor. It follows that the speed of the object is given by this speed of object, that means bn, and speed will be velocity. Okay, actually it is not a speed, this will be must be velocity, because displacement is given here. If it is considered as not distance, that means only simply distance, then it will be speed. But if we consider displacement, then it will be what? Velocity, not will be speed. So bn equals to can be written as like this. Velocity can be written as what? Distance function s, and block diagram will be like this. This is very important for you. For this xn, this is the input, xn will be the input, and yn will be output.
Sir, এই ব্লক ডায়াগ্রাম হলো স্যার কয়টা থাকবে স্যার পরীক্ষায়?
So actually this is the block diagram representation of difference equation. This is the standard block diagram for difference equation. Actually what will be difference? If difference one times, this will be block diagram like this. If two times, this two block will be two block. And how will if we take a sequence by a constant, okay, this if you're adding a constant like this block diagram, okay. So this will be the block diagram for first difference equation, and this will be the second block diagram for a second difference equation. That means Sn will be the input and A will be the output. Actually for acceleration, okay, this A used for acceleration. That means distance, this distance will be the output here, and this distance becomes velocity after dividing by what? After multiplied with 1 by t. Understand? After multiplied with 1 by t, we get velocity, and this velocity becomes acceleration. What? How? After multiplying 1 by t. This is why this is the whole output, and this is the main input. For what? This equation. Okay, that means distance become acceleration. 2 times differentiation. This is why there are two block. Okay, 2 times differentiation. First, for this first differentiation, this first block, and for the next differentiation with respect to time t, that means multiplying 1 by t. This will be the become acceleration. So output will be this. Two differentiators in series. Okay, the problem is obtained by difference equation of the process finding a second derivative. Given that bn equals to what? Velocity, what will be? Difference between distance divided by time, and in what will be? Difference between non-uniform velocity with respect to time. Okay, and this is the first diagram, and this is for the what? Second. This is the second, and these two combinedly, n can be written as like this. N is the combine of these two. Okay, here Sn is the input and An is the what? Output. Sn is the input and An is the output. Understand everybody? This is the main difference equation for acceleration. And this, for this difference equation, we are getting this whole diagram. Understand?
Yes, sir.
Okay. So combinedly, these two diagrams can be represented as like this. Okay. The block diagram for this difference equation is shown in this. Note that the difference equation is non-recursive, and so there are no feedback paths in the block diagram. The output sequence is n, that means acceleration. Acceleration is the dependent variable here. So input sequence distance, okay, s. The independent variable is n. So input will be distance function and output will be acceleration. That means this time interval what, -2, because 2 times differentiation. Understand? How many block will be here? Actually 2 blocks. To combine it, and after multiplying what, 1 by t square. Understand? 1 by t square. This is 1 by t square, and this is Sn is the input. Sn is the input, and this is for Sn minus 2. Just multiplying -2. -2 what? This is the coefficient of dependent variable, right? Adding constant. Block diagram of what? Adding constant. Constant what? -2. And after this multiplying, we get -2s and -1, right? Then combining with summation. Summation, these two will given by multiplying what? Another constant, 1 by t square. 1 by t square, we get the output signal of acceleration. Actually, this is the most important application in engineering for difference equation. Okay, now numerical solution of difference equation. Now having see how difference equation are formulated, is now proceed to method of solution. The numerical method illustrated may be applied in all classes of difference equation. Suppose you consider a given equation xn plus 1 minus xn equals to n. This is the initial value problem of difference equation. Now to determine x1, x2, x3, actually we can rewrite this difference equation. For n equals to 0, just putting n equals to 0, we get x1, okay, and n equals to 1, in this difference equation we get, for n equals to 1 this, and for n equals to 2 we get x3. Understand? Very easy for you. Now determine x4, in the given difference equation. Okay, this is actually second order differential equation. This is why two initial value problem are assigned. Understand? This is the second order. Now for k equals to 0, in putting k equals to 0 here in the given difference equation, we get x2 equals to what? 1. Putting initial value x0 equals to 1 and x1 equals to 3, we get x2 equals to 1. For k equals to 1, what will be? X3 equals to this. For k equals to 2, x4, and we have to find this x4. Can you do? Understand this?
Yes, sir, Prabhu.
Okay. Now numerical solution of the output from a digital low pass filter, another engineering application. This is the given difference equation for a filter. If A is the positive, then a filter is a low pass. If A is positive, because minus A, okay. If A is positive means what? Negative. This value negative. So we chose A equals to 0.5. So yn equal to, we can write this. Understand? Putting A equals to 0.5. Now let us examine the response of the filter to a unit step input applied n equals to 0, that is xn equals to what will be? 0 for n is negative and 1 otherwise. And n must be what? Integer. So yn will be 0 for n less equal to -1. From the difference equation, y0 what will be? Just putting n equals to 0 here. Okay. Negative will be 0 for this sequence. Okay, we get y0 equals to 1. Similarly, y1 what will be? 1.5, and so on. We can y3, y2, y3, y5 we can find out. So when numerically solving difference equation, it is often useful to form a table with intermediate results. Look like this. for different values of n minus 1 0 to 1 2. Okay, xn will be this, and yn minus 1 will be values this, and yn value will be this. Actually you have to do you have to practice it to find out these values like this. Just we have found only y0 and y1, y2, y3, y4, etc. You have to find out. Understand? Then if you plot this for different values of n up to 10, and this is the xn or yn values. Okay, xn values give this, xn values constant, right? Everybody's are one, every values are ones. Okay, this is the parallel line. Understand? But yn value difference. Okay, first value is 0 and second value 1, then another value for x1 equals to 1, x1 equals to 1, 1.5. Okay, 1.5. That means this is a curve. This is not linear, so we can plot this for input and output sequence for the low pass filter. Okay, can you do this example? Now this is our desired plan to study about the jet transform and difference equation. Okay, now solve the difference equation. This is the initial value problem. Yk plus 1 minus yk equals to 0, where y is 0 equals to 4. Y is the dependent variable here and k is the independent variable. So for k equals to 0, y equals to what? 4. Taking the z transform of both sides of the given equation. This is the given equation of first order actually, and this is also homogeneous. Understand? This is the homogeneous difference equation and also first order difference equation. Remember it. Now taking Laplace transform on both, Z transform on both sides. We are skipping Laplace transform. Now we are talking about Z transform. So taking Z transform on both sides, that means Z transform of the sequence yk plus 1 minus 3 is the constant value, 3 into Z transform of this whole in second bracket. I have written Z transform of second bracket this whole left hand side. Okay, equals to Z transform of 0. What will be? Only 0. By the definition of Z transform, we must know if you put the sequence 0, you get the value of Z transform will be what? 0. Since using the properties of linearity, we find Z transform of yk plus 1, just linearity, using linearity property, Z transform of this minus 3 into Z transform of yk. This is the linearity property we have studied in our previous lecture. There are maybe 3 or 4 lectures in jet transform. Using the first shift theorem on the, you have studied about this theorem and solved different kinds of problem using shift theorem. So you must know about this. Using the first shift theorem on the first the term on the left hand side, we obtain jet into, this can be written as jet into yk. This jet comes from what? Using transformation and using shift theorem. So jet into yk minus 4z minus 4z minus 3 into z into yk equals to 0. Minus 3 into yk z transform of this. Now writing z transform of yk equals to yz, capital yz. Then this equation can be written as what? Z minus yk will be common, so yz will be common. Just z transformation of yk represented by yz. So this can be written as z minus 3 equals to what? 4z will be written at what? Right hand side. So z minus 3 yz equals to 4z. So that yz can be written as 4z divided by z minus 3. The function on the right hand side, this is the z transform of the required solution. So inverting this from table, we can find z transformation of yk equals to what? 4 into 3 to the power k. How? How we get these values actually? From the table 22.2. Table 22.2, where do you know? We have started this. Table 22.2. Study it. Okay, this the function on the right hand side, this is the right hand side function, is the Z transform of the required solution. So inverting this from table this, we can find out the yk. That means inverse Z transformation. Okay, we get yk will be what? Just in replace of this 4, constant 4. Okay, and 3, this is the in the table. So 3 to the power k. So this is the solution of difference equation, this by using what? Z transformation. Understand? Now another example by solving difference equation with the help of Z transformation. Solve the second order difference equation. This is also second order. This is why there are given two initial value problem. Remember it. For second order, two initial value will be assigned, and for third order, 3 values will be assigned. Remember it. Now taking Z transform on both sides and using properties of linearity, zyk plus 2 minus 5 into zyk plus 1 plus 6 into yk equals to what? 0. So just taking Z transform on both sides. Z transform of 0 will be 0. Now from the first shift theorem, this will be, because k plus 2 for this uh, uh, by using shifting theorem in our previous lecture, this is the 2 for z square. Okay, yz minus z square y 0 minus z y1. Understand? Minus 5, this 5 minus 5 y, this yk plus 1 can be written as z into yz, z to the power 1. That means z power will be what? 1. This one z, and power will be z into y0 plus 6 yk, where yz equals to what? Z transformation of yk. Now substituting the for the conditions given in our by using initial conditions also, z square yz, this z square yz, and uh, y0 what? Y0 only 0. Understand? So it will become 0 into z square. Now y1 equals to what? 2. This is why this is 2z. Now this becomes what? 5 into z yz. Understand? Minus 0 into z, because y0 what? Y0 equals to 0. So this will become z into 0. Okay, 0 into z plus 6 into yz equals to 0. Now from this whole, this becomes 0, this becomes 0, and we get z square yz minus 5 this and plus 6 this equals to what? Twice z. Hence this can be written as yz taking common, z square minus 5z plus 6 yz equals to twice z. So yz what will be? Z transformation of yk, right? We have denoted this z transformation of yk will be yz. So yz equals to what? Z transformation of yk, and this is the actually z transformation. Very easy. By using z transformation, we can solve difference equation very easily. So the z transformation of this, now dividing both sides by z on both sides, dividing both sides by z, we get yz divided by z equals to what? 2 divided by z minus 2, z minus 3. This right hand side can be written as partial fraction. Okay, by partial fraction method, we have solved many examples in our previous lectures of z transformation. So this can be written as partial by using partial differentiation, 2 divided by z minus 3 minus 2 divided by z minus 1. So yz what will be? Twice z this, twice z by this, and this can be written as, that means inverting gives the solution to the difference equation. That means what? Taking inverse z transformation, and previous table 22.2, 22.2 table you must know, 22 point table. what was 22-point table? Z transformation table, this table, okay, 22-point table. This is the actually transformation k into ak for the sequence f of k, right? F of z will be what? This. Okay, f of z will be this. So for this z transformation, we can write the sequence like this. Okay, for k equals to what? K equals to 3, y equals to 2. For k equals to what? 2 into 2 to the power 2. Okay, for z equals to, for z minus 1, z minus 2, etc. We can put this just using this relation. Understand? For z transformation of this, we can write the sequence like this. Okay, understand everybody?
Ji sir, Butchi sir.
Okay, so yk what will be? 2 into, just 2 into this 3. Okay, add to the power k, and this 2 into add to the power m is what here? 2 to the power k. That means this sequence can be written from this z transformation. So this is the also the result for this second difference equation. But you have used these two initial conditions, remember it. Now you will try it at home. Okay, use the z transform to solve the following difference equation, this 5, and solve this 2, 3, 4. I hope everybody can do this. Very easy for you. Just first of all, you have to finish the previous example, then you can solve this. Understand? This will be homework for you. And and then the day after tomorrow, you have to answer this from these 3. Remember it. You have to solve. Okay. Now I have given you this lecture sheet, solution of difference equation. Okay, solution, how to solve a difference equation. There is an example. Solve the difference equation. Okay, 6 yk plus 2 minus yk minus 1 yk equals to 0. This yk plus 2 can be written as like this: yk plus 1, xk plus 1. Okay, this xk plus 1 can be written as like this: yk plus 1 or yk plus 2. Understand? Same words. So in this book, 6 yk plus 2 minus yk minus 1 minus yk equals to 0. This is the difference equation of second order. So two initial values are given, and here y is dependent variable and k is the independent variable. Remember it. By z transform, we have to solve this. Now taking z transform on both sides, we get z transform of this whole equals to z transform of 0 equals to 0. Now z transform of 6 into yk plus 2 z transform of by linearity property. Okay, z transform of this and z transform of this. Now 6 into z transform of yk plus 2, yk plus 2 can be written as z square. Okay, z power will be this 2. Okay, and minus z square y0 minus z y1 minus, and this k plus 1 for z transformation of yk plus 1 can be written as z into yz minus z into y0. Okay, then minus this. Now putting the initial values, y0 equals to what? 0, and y1 equals to what? 1. Using this, we can using in this equation, we get this 6z square yz minus 6z minus z yz minus yz equals to 0. Then taking yz common, we get this. That means yz equals to this, and this can be written as what? By partial fraction. By partial fraction method, we can write this 6 by 5 divided by 3z plus 1 and 6 by 5 divided by 2z minus 1. Okay, so and this can be written as 1 minus this can be written as what? Inverse z transformation of this. Understand? And this also inverse z transformation of this by using the table 22.2 in previous page, can be written as half into half to the power k. Half will be what? Coefficient of z inverse. half to the power k, and 6 by 5 is the constant values, and here constant values 6 by 5 this, and coefficient of what here minus 1 by 3. So this will be the yk, solution of the difference equation. Similar process 42 we can solve. This equals to uk, and y0, y1, y2 etc are 0. 3 initial value given, remember it, because this is the third order difference equation. So third order difference equation, there are 3 values assigned. Now by Z transform we can solve this, taking Z transform on both sides. Okay, as the previous example, Z transform of this minus 3 into Z transform of this by linearity property. Okay, you can write this. So in right hand side, Z transformation of uk. Now this can be written as, this is the third order, remember it. For the first time we are solving third order difference equation with the help of Z transformation. So this Z transformation of k plus 3, yk plus 3 can be written as z cube yz, okay, minus z cube y0, minus z square y1, minus z y2. So for third order we have to write this sequence, this transformation. Understand? For second, we already known from previous example, z square yz minus z square y0 minus z y1, and yk plus 1 what will be z into yz minus z into y0, difference equation. Okay, now this will be can be written as only yz transformation. This is the uk. Now putting the values of y0, y1 equals to y2 equals to all are 0. Understand? So we get what, these are 0, these are 0, and y2 also 0. So we get, just putting this all 0, we get from this lengthy equation we get this. Now taking yz common, we get what, this is actually can be written as z cube minus 3z square plus 3z minus 1. What will be, can be written z minus 1 whole cube. That means a minus b whole cube formula, a cube minus 3a square b plus 3ab square minus b cube. So z minus 1 whole cube yz equals to what can be written as z transformation of, this can be written as minus yz equals to what, 1 by 1 minus z inverse. So this can be written as yz equals to this, and yz what will be 1 by z minus 1 whole cube 1 minus z inverse. Actually this can be written as taking z common here. We can take actually z is the greater than 1. Okay, z is in this for this term z is greater than 1, and this in this term z is less than 1. Okay, so taking z common from this we get 1 minus z inverse, and this is all given 1 minus z inverse. So this can be written as z to the power minus 3 into this, and yk equals to what will be actually coefficient of z to the power minus k in this sequence. Okay, z to the power minus k according to the definition of z transform. Okay, in previous example we have solved that like this series. So visit the previous lecture. So z to the power minus 3 into 1 minus z to the power minus 1 to the power minus 4. The coefficient of z to the power what will be actually minus k minus 3, just multiplication. Z to the power minus k minus 3 in what will be this 1 minus z to the power minus 1 minus 4. So the coefficient of this will be in this series equals to k minus 2, k minus 1 divided by 6, where k greater equal to 3. Actually this is the binomial series. Do you know? This is the binomial series. Now expanding to this we get the total inverse Z transformation of this. So yk will be this sequence. Okay, similarly this is homework for you. Solve by the Z transform yk plus 1 by 4 yk equals to 1 by 4 whole to the power k, where k is non-negative and y0 equals to 0. Because this is first order, this is why only assigned one single initial value. So when k equals to 0, we get the dependent variable value what? 0. Dependent variable is y and independent variable is 0 here. Okay, try to understand this within one. Okay, solve by Z transformation. This yk plus 1 by 4 yk equals to 1 by 4 whole to the power k, where k is non-negative. Okay, and y 0 equals to 0. Actually, there is a only single initial value, initial condition, because this is the first order difference equation. Okay, so the given first order difference equation is this. Now taking Z transform on both sets, Z transformation of this whole equal to Z transformation of this. Now Z transformation of yk plus 1 plus Z transformation of this, just by linearity property, we can write this Z transformation of this. Now for Z transformation of yk plus 1, we can write Z into yz minus Z into y0. In previous example, we use these relations, and 1 by 4 into 1 by 4 is the constant term. This is why 1 by 4 into just yk, Z transformation of yk, what will be? Yz. Just taking the transformation of yk equals to yz, we get this. Now this can be written as this sequence 1 by 4 to the power k, according to the by the using definition of Z transformation, we can write 1 divided by 1 minus 1 by 4 Z inverse. This is given by table, where a equals to what? 1 by 4. A equals to what? 1 by 4.
1
By
by 4,
using
sir.
by using previous table 22.2 in this lecture. Okay. So
sir.
Z transformation of this can be written as this, where Z must be the absolute value of Z will be, this is the circle, and this circle Z is the must be circle in complex number, you must know, and this is the absolute value of Z, x square plus y square greater than 1 by 4. That means radius will be less than half. So this can be written as just taking yz common, using u0 equals to what? Initial condition y0 equals to what will be? 0. So this term will be cancelled. So only these two. Now taking yz common, we get this z plus 1 by 4 yz. So yz will be 1 by z plus 1 by 4, 1 by this. Now taking yz equals to this equals to what will be actually? Taking z common. Taking z common here, because z is greater than 1. So z, taking z common, 1 plus z in 1 by 4 z inverse, and z inverse will be 1 by z can be written as z inverse. Multiply this. Now this can be written as just equals to minus 2 divided by 1 plus 1 by 4 z inverse, and this will be plus 2 1 minus 1 by 4 z inverse by partial fraction. Okay, by partial fraction, or if you take LCM, least common multiple of this, you get this multiplication. Now just to derive the whole inverse transformation, we are using this partial fraction method. So this will give the inverse the transformation of the this, and this will give the inverse transformation of this. So inverse transformation can be taken as this, and this will be can be written as minus 2 into 1 plus 1 by 4 z inverse to the power minus 1. Okay, and this can be written as like this, and this by using table 22.2 as the previous example, minus 2 here I equals to what? Minus 2, and this coefficient of z inverse, okay, to the power k, and here this is the a2, and coefficient of z inverse 1 by 4 minus 1 by 4, but you have to take positive. If they are minus, then you can take positive. If they are plus, then you can take negative. And using the Z transformation table of 22.2 of this lecture. Understand everybody? This is the result. This is the actual solution of the given first order Difference equation, not differential equation, remember it. Similarly, this 44 example, like this example we have solved previous example, UK are present, understand? And UK, this is another sequence, UK, U is the dependent variable and K is the independent variable, and in this Y is the dependent variable and K is the independent variable. So left hand side and right hand side are different. Now taking that transform on both sides of one, we can write this, and YZ will be the Z transformation of the left hand side and UK will be the Z transformation of right hand side. So this YZ can be written as, and UK, and this divided by this 1 plus 1 by 3 Z inverse 1 plus 1 by 4 Z inverse, and this UK will be the normal sequence. So YZ can be written as like this, and Z inverse, multiplying Z on both numerator and denominator, we get this, multiplying on Z. There is only one simple pool, that at Z equals to what? Z plus 1 by 4 equal to 0 to find out this pool. Now Z equals to 1 by minus 1 by 4 will be the simple pool. Let us consider the contour Z greater than 1 by 4. Then residue at Z equals to minus 1 by 4. Now we are using residue theorem. We have applied this residue theorem in our previous lecture in this sheet. Okay, in our previous lecture we have used this residue theorem. At Z equals to minus 1 by 4, Z plus 1 by 4 to the power Z to the power minus K, according to the definition of Z transform, and this Z plus 1 by 3, Z plus 1 by 4. At Z what equals to? Z equals to minus 1 by 4. And at Z equals to minus 1 by 4, putting Z equals to 1 minus 1 by 4 here, we get this result, Z to the power K plus this. Just putting Z to the equals to minus 1, Z to the power minus 1 by 3, we get this. We get this. Okay. Now this is the actually YK. This is the value of YK. These two combinedly can be written as like this: 1 by 12 minus 1 by 4 to the power K minus 1 combinedly. So hence the solution of difference equation YK can be written as residue of this equal to this by using residue theorem. First of all, we must know about the residue theorem in Z transform and how to solve Z transformation by using residue theorem. You have to study first, then you can solve this example. Similar way, you can solve this difference equation in right hand side cos chi pi by 4. This is the inhomogeneous, not homogeneous difference equation. So because cos function are present here, and this is how many order actually? How many order? Can you tell me? Second order. So similar process you can proceed on, just how to solve the transformation by using residue theorem. Again, there are how many pools? Actually 2 pools. Z equals to 1 I by 5 one pool and minus I by 4 5 is another pool. That means this Z square minus I square by 25 can be written. Okay, this will be 0. Z square minus I square by 25 will be 0. So Z plus I5 into Z minus I5 equals to 0. So how many will be values? Z equals to 2 values. Z equals to I by 5 and Z equals to minus I by 4. These are 2 poles. Considering this, Z will be greater than 1 by 5. Okay, this is the last phase. Z greater than 1 by 5, we get Z equals to I by 5. Just putting in the residue theorem of Z transformation, remember it. Okay, just using previous examples of previous lectures, by using that residue theorem in Z transformation, we get the result of this. And at residue Z equals to I minus I by 5, minus I by 5, then we get this similar process. I transform to minus I just. Okay, this is for Z equals to I by 5, but if you want to find out z equals to minus I by 5 at this, just transforming I to minus I here to get this. So yk will be sum of the residues. Yk will be what? Sum of the residues. This is the residues here, and this is the another residue. So 1 by sum will be what? Sum will be 2 into this 1 by 5 to the power k. This will be sum. If we take common, sign will be cancelled. Okay, and cos chi 5 by 2, cos chi 5 by 2 will be single cos chi 5 by 2, 2 cos, and 2 and 4 will be cut. This will be the result. And 46, this 46 will be example for you, and this will be homework for you for different values of this sequence difference equation. This difference equation have different values for k depending on k. By residue method, using residue method, you have to find out this. Okay, now I hope
Yes,
everybody
sir.
can do this difference equation by using Z transformation. Okay, solving difference equation by using Z transform. But first of all, you have to try to understand what is Z transform and what's the properties of Z transform. And using properties of Z transform, we have solved many problems in our previous lectures. This may be 4th or 5th lectures. Okay, visit another all lectures in YouTube, then you can find out the how to solve jet transformation and all about jet transformation in previous 3 lectures. So in these lectures we have studied about jet transformation and difference equation. Okay, properties of difference equation, types of difference equation, order and linearity of difference equation we have studied, and homogeneity of difference equation. Okay, and how to solve difference equation and how to use in engineering application of difference equation we have studied. Then at last we have studied what is the transformation and how to solve difference equation by using jet transformation method. So to solve this problem, first of all you have to find out what is Z transformation and how we can solve, how you can find Z transform of any sequence. Okay, today is the ending of this class, so best of luck to everybody.